Hello, this is an example problem from chapter 14. This is on page 575, example problem 14.1. The problem statement is, a catalog lists the basic dynamic load rating for a ball bearing to be 7,050 pounds for a rated life of 1 million revolutions. What would the expected L10 life of the bearing if it were subjected to a load of 3,500 pounds? Okay, so essentially what they're asking for here is you can expect a bearing of this design to last for 1 million revolutions if the load was 7,050 pounds. That's based on manufacturer's data. Now, if you were only loading that bearing to 3,500 pounds, how long would it last? That's the gist. Okay, so the background. All bearings have a finite life. A bearing with a lighter radial service loading is expected to last longer than the same bearing that has a heavier radial service load. Bearing manufacturers publish data to help designers select the proper bearings for their application. So if a bearing is selected properly and lubrication is properly maintained, the bearing is eventually going to fail due to fatigue over a large number of cycles. Bearing life is determined as a number of revolutions until failure and is predicted based on statistical methods. Statistical bearing life is reported in manufacturer's catalog data based on loading and is typically based on a service life of 1 million revolutions. Okay, so let's talk about some definitions here. First of all, C0. You'll find that in table 14.3. This is the static load rating for a bearing. Basic static load rating, that's a load a bearing can stand without permanent deformation of any component. C0 is reported in the catalog data. Now C, which is the basic dynamic load rating, that's this one right here, this column right here, is the manufacturer's catalog, and this is the loading that results in the L10 bearing life. Now what's the L10 bearing life? It's the rated life. When loaded to the basic dynamic load rating C, 90% of a sample of bearings would achieve a life of 1 million revolutions. And that means 10% would fail before achieving the 1 million revolutions. That's what I'm talking about, a statistical analysis done by the bearing manufacturers. So the bearing manufacturers will publish one set of data relating the bearing load to the bearing life. It's up to the machine designer to consult this data and select the proper bearing for an application. Okay, so let's look at table 14.3. What do we need to know about this table? The table is only applicable for single row, deep groove ball bearings from a specific manufacturer. The L10 life is not explicitly stated in this table. It's assumed to be 1 million revolutions. That's 10 raised to the 6th. Now, for each shaft size, there's typically 3 different bearings that have different dynamic load ratings. Okay, you can see this here. For 10 millimeter shaft size, we have 3 different ones, and then for 12 millimeter shaft size, we have 3 different bearings, and those different bearings will have different load ratings. And then the installation data and bearing mass are given in this table as well. So now let's talk about our problem. So I'm restating the problem here. So given, in this case, what is given is P1. That's C, which is our dynamic load rating of 7,050 pounds. What's also given here is C2, P2, which is our design load. And that's what we're expecting our bearings to be loaded for this application. Now L1 is the million revolutions, 10 to the 6th. That's the L10 life at load C1, and then K is always going to be 3 for the ball bearings per equation 14.1. So, solution. Okay, we're going to use equation 14.1 for this solution, and this relates bearing life to load. Okay, so in this case, what we're going to do is we're going to solve this equation here for L2. Okay, so L1 is the predicted life in number of terms at dynamic load rating P1, and L2 is the predictive life in numbers of turns at dynamic load rating P2, in which case we solve for L2 and we get 8 million cycles. Okay, so what does this mean? At a dynamic load rating of 7,050 pounds, the bearing manufacturer predicts that 90% of the bearings will survive 1 million revolutions. The designer for this application has calculated the radial bearing load at 3,500 pounds, which is a lot lower than the dynamic load rating. So then we used equation 14.1, and the designer determined that in this application, 90% of the bearings are going to last in excess of 8 million revolutions. This explanation should help you with the first two problems of your Chapter 14 assignment.